Now, our basic circuit, we have voltage, we have current flowing up through here, and at some point in time it's going to hit a resistor. And if all we have is just one resistor, then V equals IR, you have the resistance, you can calculate current. If you have the current, you can calculate resistance, etc., provided that you know the voltage. But as in the case with capacitors, we could have situations where resistors are put in parallel with each other or series with each other. And the first case that I'm going to look at is the case where there's two resistors in parallel with each other. Now, remembering that for each one of these, the current that flows is going to be based on Ohm's law, okay? And we have two resistors up here. Well, we have a resistor here, we have a resistor here. As the current flows through here, it has to flow through that one, and the same current has to flow through that one to come around here. So we have some total voltage, and that total voltage is going to equal to the current, whatever that current is, and the total resistance. And what resistance that we have when we look at this, it has to flow through both of those in order to travel back to the other side of the battery, so that our total, when we are in series, as this is you just add the two resistances up together. So for instance, let's say that our voltage is 20 volts. Let's say resistor 1 is 150 ohms. Let's say resistor 2 is 250 ohms. I look at the total resistance. Resistance total is 150 plus 250. It's 400 ohms. And I say, okay, well, the voltage is 20, the total resistance is 400 ohms. So if I want to know what is the current, it would be 20 over 400, which looks like 0.05 amps or 50 milliamps, okay? And that's how much current has to run through the whole thing. But if we think about what this voltage is doing, this voltage has to push it through this resistor and has to push it through this resistor. And a portion of the voltage is spent here. Voltage is just that how hard it's pushing, and part of it is spent over there. And of course the total voltage has to be 20. But if we look just at this resistor alone, for that resistor, R1, and we want to look at how much voltage was dropped, we say across R1, it would be I1 times R1. Well, we know I1, at 0.05 amps, that's everywhere. So V1 is going to be 0.05. And then we look, and R1 was 150 ohms. And so that's going to give me my voltage 1. Let's see, I'm going to move that 2 decimal places and move this one 2 decimal places. It looks like 7.5 volts across that first resistor. How much voltage is across the second resistor? Well, V2 will be the current 2, and current 2 and current 1 are equal to each other. R2, and current is 0.05, R2 is 250, and when I do that math, I get 12.5 volts. And of course the 12.5 plus the 7.5 adds together to give me 20, as it should. And we can say there's 7.5 volts dropped across the first resistor, 12.5 volts dropped across the second resistor, and overall there's 50 milliamps of current running through the circuit everywhere.